are talking about the power industry in this issue, mainly thermal power. That is to say, a large electricity user in water treatment. What did he do? What kind of water? How does it work? Everyone knows the thermal power industry. Traditionally, the thermal power industry is actually composed of two energy sources. Which two energy sources? One is coal, one is oil, and then thermal power. The idea is to generate heat by burning fossil fuels. That is equivalent to this process. In fact, I don't fully understand it myself, but I put roughly this framework today. Move it out for everyone. First of all, fossil fuels. It cannot directly concentrate the energy, generate electricity. So how did it come about? This piece involves something we often encounter. Boiler. Fossil fuels generate heat. Combustion generates heat energy to the boiler. There's water in the boiler. During the heating process, water in the boiler, it turns into steam. Steam. After forming steam, once the steam expands, steam has a very large kinetic energy. Then this kinetic energy of this steam, the steam will be sent to the turbine. Turbines, you can imagine, to put it simply, it's like a windmill. Just like playing with windmills when we were kids, and you take a windmill, you take a breath out of your mouth. Then the windmill starts to turn. Then you can imagine, heat is steam, then blow over. And then this impeller of this steam turbine starts spinning like crazy. What happens then? That's heat. One of the steam pieces first. It's like he stored steam. This piece is stored, become a kinetic energy like a mix of thermal energy. In fact, it is mainly moving. Then the steam powers the gasoline engine. Time. And then the whole kinetic energy undergoes a transformation. And the turbine turns. Then kinetic energy becomes conductance. This is a process in the entire power generation industry. So what does this have to do with us? The one that is most relevant to us is the boiler. Please understand. Fossil fuel burning boiler. Water in boiler. This water must be desalinated water. Everyone understands. When we let's boil water in a kettle. It's been burning for a long time. Are you the inner wall of the kettle? There will be layers of scale coming out. It doesn't burn once, it burns more than our kettle. If our kettle may burn, you say after the water boils, then there's a deflated one on your one, then one eye, and then the breath can still come out of there. There are also sounds reminding you that the water is boiling. Then you have to remove it. Boilers are divided into low-pressure boilers and medium and high-pressure boilers. Whether it is a low-pressure boiler or a medium and high-pressure boiler, its pressure is very high. It is definitely much higher than the pressure of our kettle, because it's all over this boiler. You're only under extreme pressure. To ensure a continuous supply, vaporize this vapor, then send the steam out. Then the water in this boiler is, you can imagine this boiler. It works 24 小时, hours a day, are constantly going out through heat energy conversion. Keep steaming water into steam. In the process of steaming into steam, please understand. When the water vapor goes out, it's just water. Other things in the water vapor cannot be taken away. Then if we use this water, if it's not desalination water, my water goes into the boiler. Then the boiler starts to steam. Then it has this evaporation effect, become a source of water vapor. The source keeps going out. If my water is not clean enough, will I have a lot of impurities? Just go out with the water. A large amount of impurities remain in the boiler. The inner wall of the boiler will form particularly thick scale. What phenomenon will this lead to? I still have a lot of heat to heat the boiler. The structure of scale is not uniform. Let's say we draw boiler. I've got such thick dirt on my side. There's such a thin scum here. What phenomenon will occur in my whole boiler? Uneven heating. What can cause the boiler to explode due to uneven heating? So this is a very serious issue. Is this boiler all that kind of oversized boiler? Especially the boiler that matches the thermal power plant. So this thing. There must be no security incidents. If it happens, it's a major security incident. So you can understand. The water requirements are very high. That desalination water is very important. The water we get into the boiler can't have anything. The cleaner, the better. The purer, the better. So, we must remove the salt and ions from the water. To remove, his request is more than what we just talked about. The drinking water mentioned earlier. That one is much taller. What to ask for? General boiler makeup water. There is a clear conductivity requirement. Less than 0.2. Less than 0.2 cm. What does this indicator mean? This indicator means that the reverse osmosis membrane. The membrane cannot reach this indicator. So that's it. If the membrane cannot be reached, something new will have to be reached. Then this piece will be derived. Equipment that our company has not made at present. There are two ways to choose. One is resin. We still know this better, but we often use is softening resin. And then there's this thing called ED. These two things can be used after the reverse osmosis membrane is achieved through the production of salt, the most commonly used in the power plant. This is the water making process. The power plant calls this pure water chemical water. How is it made? First of all, the front is a double-stage reverse osmosis. And after double-stage reverse osmosis, add mixed bed or ED. Can achieve this target because they use a lot of water. Its system, usually a few hundred meters per hour. This one processing volume. So power plants are big users. Our country, this amount of water for the power plant. There are clear requirements, and he uses so much water. The state will never let him use drinking water because the quantity is too large to afford. You certainly can't dig underground because you'll empty the groundwater. So the water that power plants often use now is reclaimed water or surface water in a river channel. Reclaimed water, rivers, lakes. Both of these waters mean that this water is particularly bad, not clean. No drinking water and clean well water. What do you do now? So the electric field is to stage reverse osmosis. There is a very strict pretreatment ahead. Generally used ultrafiltration that we basically can't come into contact with now. Ultrafiltration will be added in front of reverse osmosis. The front of ultrafiltration, maybe with some other pretreatment, including the multi-electron filters we use. They also adsorb with activated carbon. Sometimes it is also used. There may be related sedimentation tanks, but the ultrafiltration membrane is relatively close to us. Can everyone see it? Now I draw these products. Both products we may have come into contact with before. Ultrafiltration membrane, reverse osmosis membrane, resin, ED. If you want a power plant, we can do. If you come down, then this volume. At least a few $100,000. Such a volume. Basically the power plant water. So that's it. I want you to understand that. Let's say the power plant is a big user of water. Then the power plant produces salt water called chemical water. Then the power plant, his entire water quality index. There is a basic requirement. That's less than 0.2 microsiemens. So he is very strict about water requirements. His main process is not just reverse osmosis. Then he has to have a deep salt production behind him. Then in front of him. Because he is a big user of water. So his water is very dirty. That means there has to be more sophisticated pre-processing up front. Therefore, ultrafiltration membranes are often used. That's basically all for today.